That's on videotape, I just realized that. We've been dealing with this in California for only a very short period of time. And I think that some of the questions that have come up are important questions. They're ones that we need to address, but ones that we haven't had a chance to look at yet. So a lot of what I'm going to talk about today is no data, it's speculation. It's sort of setting the scene for what we're likely to be facing. The title on this is important in that the key word on this is complex. We're looking at an environment that is very, very complex. It's complex in lots of different ways. We're looking at an environment that is spatially complex, it's structurally complex, it has a complex species diversity, it has complexity in use, it has complexity in the susceptibility of the trees that are there, it has complexity in the way that those trees are taken care of and the culture of those trees. We're looking at an ecological environment that's complex on many, many different levels, and we'll spend a little bit of time talking about that. Okay. Some of you who are familiar with Riverside would recognize this, and hopefully tomorrow when you come to campus, we'll pass through some of this. This is the UC Riverside campus in the agricultural operations area and the surrounding neighborhoods associated with the campus. And I want to use this as an example of the different kinds of complexities that we're going to be talking about, because the beetle is going to use that environment. There are no barriers in that environment. They're going to be moving back and forth across different portions of that environment. And the risk to any particular tree is in part a function of the complexity of that environment. So we'll look at a couple of specific examples. Here's one spot on the campus. The entomology department is right in here. There are a number of the buildings associated with the plant pathology department in that circle. If you look at it closely, here's the quarantine building for the entomology department's quarantine building. And here's an avocado grove. It's part of agricultural operations, but it's surrounded by a campus and the landscaping associated with that campus. It's also surrounded by wildlands, undeveloped parts of the campus. So the insects that are moving in that environment are encountering a very diverse environment, both in terms of the tree species that are there, the physical structures that are there, the way that the landscape is cared for, the amount of watering that's in this environment, very complex. Here's another area. This is the agricultural operations. It's 600 acres, Peggy? Close? It holds a citrus variety collection. It has a tremendous number of experiments that are being done there. And right in the center, there's another avocado grove. But this one's surrounded by a riparian zone, various field experiments that are there, citrus, but there's also neighborhoods around it. Those neighborhoods are landscaped. Some of them are well cared for, some less well cared for. There are street trees, a wide variety of street trees, some of them susceptible hosts, some of them not susceptible hosts. A lot of these neighborhoods, people have fireplaces. They're bringing in firewood from who knows where. That firewood may or may not be infested with a variety of insects, and potentially this particular ambrosia beetle. Just across from that, in this corner, we have a park, a neighborhood. Again, you can see a wide array, a wide diversity in the environment. All of these landscaped homes, a wide variety of tree species that are there, a wide variety of potential hosts, a wide array of cultural conditions. Some places those trees are overwatered, some places they're underwatered, some places you have concentrations of susceptible hosts. You may have concentrations of very resistant hosts. So movement of beetles through this environment is unpredictable or difficult to manage. One last one. This area here. This is part of a county park. It's Sycamore Canyon. If you look closely, there's a riparian zone that runs through that, and there are large numbers of sycamore in that riparian zone. Remember from yesterday, sycamore was one of those trees that was frequently attacked. So here's a potential source of beetles. For managers of that park, those trees are very important. They are an important resource that needs to be protected. But they also can be a source of beetles for movement in and out across these boundaries, the boundaries between the interfaces between urban landscapes, agricultural landscapes, and wildland landscapes. So trying to deal with management, control of an insect population in this ecologically diverse and complex environment creates a whole series of very important challenges. As I said, there's structural complexity, there's community complexity, there are barriers and there are corridors for movement. So management has to take into account these barriers and corridors. Yesterday, Keith was saying that the 57 freeway marked the boundary. The beetles didn't cross the freeway. Well, we know that's not going to be the case. But freeways can be barriers. There are also corridors, and it's something that we need to be very aware of and very careful of in terms of assessing risk to different environments or sub-environments. There's a possibility for host reservoirs and refuges as a result of this, as part of this complexity. And there's different values and different suitability for control tactics. Jocelyn talked about landscape trees. They have a very different value than a wildland tree. And the control options might be very different in different environments. Now, it's important, as Jocelyn pointed out, to understand the biology of the insect and how it fits into this complexity, this environmental complexity. There's a lot of background information. There's a lot of information on closely related species or subspecies or subgroups. We need to know more about the life history and the reproduction. We're just getting started on that. Richard has 4 months worth of work, and it's giving us substantial amount of information on the biology of the beetle. We need to look at the environmental limitations. There are good models available for the tea-shot hole borer in Asia, but are those models going to be transferable for this beetle in Southern California? It's going to be something that we need to look at. We need to look at the hosts that are at risk. The botanic gardens are outstanding arrays of plants that give us an idea of what plant species are going to be susceptible or most at risk. We could look at those trees and see which ones have been attacked, but we also need to look at which ones are appropriate, which ones are suitable for producing brood. It's a very different kind of question. The seasonal activity, again, there's a lot of information that is available that we can build on, but we need to look at this in terms of the local environment. And we need to look at movement. This becomes particularly difficult given the challenges that Jocelyn just pointed out. How can we assess movement if we don't have a real good attractant, if we don't have a real good way of trapping the beetles, of monitoring the movement? How far can they move? How long can they move? When do they move? And how do they distribute themselves through this complex environment? So these are all issues that we need to deal with in Southern California. This is not just an insect problem. Again, we have a complex. We have an insect-fungus symbiotic association that we can ask separate questions, but really to understand the system, we have to ask those questions of that complex, not of the individual pieces. So what are the associates? What's their role and their interaction with the hosts, with both the insect hosts, the interactions between the insect and the fungus, and the interactions between the insect and the tree and the fungus as a complex? How do the fungi contribute to the fitness, to the success of the insect? And looking at the various fungi that are present, do they interact with each other and contribute to the success of the beetle as an association? Do we have an opportunity to look at some of the questions that Diana's been addressing with mountain pine beetle, where the fungal complex can change throughout the year depending on the environmental conditions? This may be something that we need to pay attention to in Southern California. And how do the interactions affect the spread, particularly the spread from tree to tree or long distance spread? So we need to look at movement. We need to look at routes of movement, both facilitated movement, which is a euphemism, I suppose. Firewood is an incredibly important source of movement of these wood-boring insects. So we need to look at facilitated movement and directed movement. Look at the way that they move, identify the routes of movement. And then compare with previous efforts, work that's being done in Israel, work that's being done in Florida, work that's being done in Asia. Where are the successes? How can we build on the successes that other researchers have already, the breakthroughs that other researchers have already made, to build on those? So there are a number of approaches that we need to look at. This gets to Randy's question from during the last session. Where are we going with this? How do we make recommendations to the growers? We need to look at trapping. Try and look at trap design, test them out, look for lures, look for attractants, look for repellents, look for ways of improving trapping efficiency, looking for attractive lures. Looking at biological control. Are there native natural enemies that can shift over or will shift over or have shifted over onto these new hosts? What is the potential for introduction of natural enemies? Not great, I suspect, but we have to look at this as a possibility. Biological control of the fungal associates, another possibility. Looking at microbial control. We've seen Bovaria may be a potential. In this environment, as dry as it is, maybe not as high a potential as in the tropics of Queensland. So we need to look at that, explore it. We need to look at various kinds of chemical control. We're going to have a number of talks after this one dealing with use of insecticides in other parts, and particularly in Israel, other parts of the world. Systemic insecticides, contact insecticides that provide barriers. Not necessarily an appropriate approach in all circumstances, but there are or potentially can be uses of insecticides that will fit with the value of the trees. This is something that we will be testing, and information made available to the growers that provide some options for kinds of things that they do. The value of the tree and the cost of the control have to be balanced out in some real way. Cultural control, sanitation. For wood-boring insects, these are critical. Removal of sources of beetles, tree removal or removal of infected material or infested material, treatment of slash and debris in a variety of different ways, including chipping and grinding, not tested in California, good success in Florida, something that we need to look at. Solarization and composting, things that have been done. This is actually a test that we did with a longhorn borer probably 15 years ago, wrapping infested logs in black or clear plastic and putting them out in the sun. Will that kill the beetles that are inside? Is it a way of disinfesting wood material? And firewood movement, something that we need to make people aware of, that when trees are felled or branches removed, that it doesn't instantly transform into another resource, that it actually becomes a source of movement of these insects. So implementation of research is something that will come with time, but we need we have sort of short-term and long-term goals in the research program, looking at new species in a new environment, starting with the experience of others and building on that in California, adapting these approaches to California conditions. If we can do that, then I think we have a chance of providing tools that can be made available to both the agricultural industry, the avocado industry in particular, but also to the arborist communities, to the landscape communities, to the institutions that are charged with managing parks, street trees, recreational resources, the natural environment, the governmental agencies responsible for protecting wildland trees. Hopefully we'll have those tools available to have some control options available. So that sort of sets the stage and says a little bit about where we're planning on going. The next set of talks will talk about specific experiences. So thank you very much.